Is my screen visible? Okay. So let's come to the first question. First question is very simple. That is, Seth has traveled a long way and now wants to get home. Seth, D, Seth is D kilometers away from the home and he can walk at a speed of 1 kilometer per hour. Right. Seth also has ability to teleport. So he can teleport for a distance at most 3 kilometers, which happens instantly and doesn't require any time. The teleporter can be used at most once. So we have to find the minimum time in hours that Ceph needs to reach home. So it's a pretty straightforward question. So we have given D, that is distance. You can say the distance between their home and the position of the Ceph, and he has a power that is he can teleport to a certain distance, that is T, and he can use at most once. So have you can you share your approach? It is a very easy question. So
Yeah, it was pretty easy. Just subtract the teleportation distance from the actual distance. If it was negative, then we print out 0, and if it is not, we just print out the number that came up because he walks at 1 kilometers per hour. That's how we much.
yeah, yeah, it's similar. I take a maximum of zero and difference that you told. So it is the same. Okay. So I hope it is clear, very easy question it is. So let's move to the next question. Yeah. And football players stand in a line in order to practice their passes. The players are numbered to 1 to n. Initially, player 1 is the ball. All the players have a passing power of k at any point of time. If the player x has the ball, x plus k less than n, the ball will pass to the player x plus k. Otherwise, the ball will remain with the player x. So you are given n and k. Find the number of players will have the ball in the end, given that player one start with it. So we have given with n and k, and we need to find the number of players who will have the ball in the end. So if I go to the board, what the question is saying, there are n players, right? And all the players having the passing power of k, like all the player can pass the ball to the next k person, right? So we need to find the number of player that in, like who will have the ball in the end. So it is also a very if I show you the some of the test cases, that is if x equal to 1, so each player passes to the next one. The ball goes from player 1 to 2 and 3 to 4, but player 4 can't pass it further. So our answer is 4. So can you share your approach for this question?
Yes, I first put an integer, let's say I is equal to 1, and ran a while loop till I plus k exceeded the value of n, and every time did I change the I value to I plus k, and whatever the final I value will be, it will be printed out.
Okay, like you use the while loop. Yeah, mine approach was also similar. If I show you, okay, I take a like field value. So your in this question, the constraint is very little, so you can use brute approach. But my approach was a little Let me give a second. So we have given n and k, right? So we need to find like how many players can have a ball in the end. So as you told, like we can use a while loop. It is a brute approach. So what I have done was I take first n divided by k minus one, right? So one second. So sorry, n minus one. Where is it? Where is it? Okay. It's control. So I take n minus one and divide it with k, right? And then we multiply it with k. So what this will give us, it will give, look, if this will give us the store value, right? And if we multiply this, we can go to the actual position. So if I take any test cases, suppose this 5 and 7, okay, sorry, this 5 and 3. So if we divide 5 minus 1 by 3 and then multiply it with 3 again, so it will give us 3 because we have taken the floor value and then multiply it with k. So if we verify it with the test case, it is showing 2. Okay, there is some mistake. Okay, 5 and 3, right. So what I've done was n minus 1 upon k into k. So I missed that this division. If I divide with, so yeah, leave this. Your approach is correct. We can use while loop. Uh, we can use any true value and we can break after when we not able to move forward. So you are telling like you are incrementing the ith value. So if I initialize I with 0 and we are incrementing I up to k, I plus equal to k, right? And when we reach our destination, we are simply breaking it out, right? Am I audible or no?
Yes, 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 bhaiya.
Okay. So your approach was this now, like you are implementing it with k, and when you reach the position n, you are simply breaking it out.
Yes, bhaiya.
Okay. So let me rethink my what was my approach. I'm not getting. Give me a second. Uh, k and minus one by k into k. So I am taking a C value when I type it. So why this is not running?
Bhaiya, I guess this is example of first question.
Okay, okay. Yeah, yeah. Thank you, thank you. Yeah. If I take this example, that's why I'm thinking why this is going wrong. So if I take C value of this and divide with let me close this. divide with k, that is 1 here, then whole into 1 plus 1, because this will allow us to reach at that position, and we can pass that, the person will can pass one more player. That is why we are implementing it by one. So yeah, it is. Uh, I am taking the wrong test cases. So I hope this is clear.
Yes, bhaiya.
Okay, okay. Let me close this. So let's move to the next question. Uh, Deep in a forest live a bear and a rabbit. The forest has n clearings, numbered from 1 to n. Clearing I has AI carrots growing in it. The bear patrols several zones of the forest, especially you are given integers L and R such that bear patrols clearing between N and R. It is guaranteed that either L is uh, greater than 1 or R is less than 1 and N is less than, sorry, R is less than N. That is, there exists at least one clearing not patrolled by the bear, and rabbit can move uh, one left side, like adjacent left, or he can move adjacent right. So, like the rabbit cannot jump the position. Like he can only move front, like one step forward or one step backward. So, if I show you the, suppose this is a, suppose there are n clearings, and all clearings have some carrots. Suppose in this three, this clearing has 2, 4, 5, and 6, and we have given with uh, a peer that is patrolling some area, and we are given with some L&R where the bear is patrolling. So we cannot take rabbit from that patrolling area. So suppose consider a case where that bear is patrolling in this area, right? So like rabbit can pick from this or this. Like you cannot pick from the patrolling area. This is the question. What was your approach, Arnav, if you want to share? Like,
Yes, Bhaiya, my approach was also something like this. I just saw what was the least element of the array where bear was roaming, the least AI, and the max AI till which the bear was roaming. Uh, on the left side of the least one, I calculated the sum of all the elements, and on the right side of the max one, I calculated the sum of all elements, and whichever one was the max, I just printed it out.
okay, you are saying you are isolating the like patrolling area and calculated the sum of element of this side and this side, right?
Yes, Bhaiya.
And returning the maximum value among them.
Yes, Bhaiya.
Okay, okay. That was same approach as me. One second. I have done the same thing. Uh, First, I take input LR, and I am decrementing it because I use zero-based indexing. And I go out till L and find the sum. So LF is the left sum and RT is the right sum. So I return the maximum among them. So it was a pretty straightforward question. So I hope it is clear.
Yes, Bhaiya.
Okay, so let's move to the next question. You have an array A of n integers. In one operation, you can do the following: choose any index I and update AI with AI with floor of pi upon. Find the minimum number of operations needed to make all the elements equal. So the question is saying we have some given numbers in an array, suppose 2, 5, 7, and we need to make all the elements equal. And in one operation, we can divide any element by 2. So for this case, if I show you what will be the optimal answer, so I am dividing 5 by 2 in one operation. So it will become 2. And in second operation, we will be dividing 7 by 2. So it will give 3. But it is not the same. So again, we need to divide all the elements with 2 to become to make all the elements equal. So after this, our operation was 2. So I am storing it here. So for making 2 to 1, we will require one operation. And for this, we'll also require one operation. And for this, we'll also require one operation. So, so total operation will become 5. So this is the question. And so can you share your approach or no?
Yes, Bhaiya. First, I checked if all the elements are same or not. Simply print out 0. If not, then I ran a while loop and sorted the array every time. So we get the minimum element at first, and we know that we do not have to deal with minimum element. Rather, the max element should be bring down, and ran the while loop till all the elements were same.
Okay, okay. So you are telling like something the array is given. Consider this array only 257. You first sort the element of all the array, and you are not dealing with the smallest element. You are taking only the largest one and divide it by 2, right?
Not only largest, all the elements that are larger than 2.
Okay, okay. Except the minimum one, right?
Yes, yes, wait.
Okay. So you are dividing all the elements except the minimum one and making like counting all the operations, right?
Yes, Bhaiya.
Okay, okay. Yeah, the constraint was a little looser, so we can go with the brute one because n is very less. So, like, have you, can you say what was your complexity of the approach, time complexity of your approach?
Yes, around n square to n cube.
Okay, so let's write your logic. You are running a while loop, right? And I am taking a true value, and you are sorting first all the element, right? Here I can write direct the vector. Now you are telling except the first one. So you are taking a for loop and going from index 1 to n minus 1, right? And dividing it all the elements by 2, right?
Yes.
So your approach was like this.
Yeah.
So now you tell me the time complexity of this uh, approach because it is very important to know what is the time complexity of this approach.
I mean, it also depends on the volume. I mean, sorting algorithm was basic n square time complexity, and the while loop could have the best case or the worst case, depending on that.
No, like time complexity generally means the worst case scenario. And suppose like I'm calculating now. For sorting, it requires and log n, right? Okay. And for this one, you are going to like close to like you are going to n minus one number. But
Yes,
so we can generally say we are looping to n numbers, right?
yes, भैया.
And this while loop, like what is the like what is the function of this while loop? Like when it will break, it will break. Suppose I have a number in my array that is 13. So in each operation, you are dividing it by 2. Consider case where it is not the mean, right? Like in first for loop, you are dividing it by 2, it becomes 6. Then in another operation, it will become 3. Are you getting what I am saying in this 13?
Yes, भैया.
Yeah. So this while loop will depend on the maximum element that is present inside the array. Agree?
Yes, भैया.
So suppose our maximum element is m, and in each operation we are dividing it by 2. So and what value which like what will be the last value we can make it to? Like we can make it up till 1, right? Because after 1 it will become 0, and that is not a point.
Yes, yes, भैया.
So from converting n to 1, uh, how many steps it will take? If in each operation we are dividing it by 2. Any idea? Suppose I have a 22. In one operation we convert it to 11. Then in another operation we'll be converting it to 5. Then 2. Then 1. So is this a random operation? Like is this the count is random, or it is a like any formula is there? How will what will be the number of steps to converting this to this? If we are dividing,
Uh, l-
okay, okay. This will
just
equal, okay,
login.
okay. This will require log base 2 m time, right?
Yeah, okay, yes, भैया.
Okay. So, so now what will be our total time complexity? As we have, and we are taking an operation here, and log n for sorting, and here we are taking log m, right?
Yes, भैया.
And what is m here?
The largest element among
Okay.
all.
So what will be our overall time complexity? That will be n square log n log m. Agree?
Yes, भैया.
Okay. So this this is little important to know. Like the question is the question is tool list. So before attempting the question, if we have a rough idea, like will pass our constraint or not, so it will become little easy. My approach was little optimized one. I have taken. So let me take a case. Suppose this one 489, because this question is repeat this question has came on code process contest last time. That's why I used that word. 489 and 23. So I just first try in the uh, test case. So then I first divide by 2 and it become 2, and then I divide 2 1. For 8 we are doing the same thing. Our main goal is to reach the last number, that is 1 in the current scenario. For 9 it will become 4, then 2, then 1. For 23 it will be 11, then 5, then 2, then 1. Our main goal was to make all the elements equal. So if we see this, 1 second, uh, suppose 4. 4 is, can we able to make all the elements equal to 4? So if we see this table, we can make the first element equal to 4. Second, we can also make, third, we can make, but fourth one, with any operation, we can't convert it to 4. So we'll be leaving this. Now, if I talk about 2, we can convert the first element to 2, then second element also to 2, third also, and fourth one also. So it is the valid case, like we can convert it to 2. Similarly, for 1 also, 1 is the universal, you can convert all elements to 1. So I take a map, and what I was storing is, in my key part, I was storing the number, that is 4 or 2, you can say. Right? So in first part, uh, I was storing key value, and in second part, I am storing it as a pair. So let me directly write it. In second part, I was writing storing a pair. Uh, the first part of pair will be storing the frequency, like how many times these are coming. Like for 2, it is 4. For 4, it is only 3. So first part was for storing the frequency, and second part was the, like, for reaching to how many steps we are taking. In the first case, we are taking one operation, right? And for these two, how many operations we are requiring. For 8 to From 8 to 4 we are taking one operation, then again from 4 to 2 we are taking one more operation. So we are adding that total operation in that key value, that is for 2. So first one for frequency, and second one for the total operation for reaching that position. Like, so you can say total operation. Right. So and in our map, if our frequency is equal to the total number of elements, what it means is our we can make all the elements to that number. So if our total, if we have the frequency of 2 is equal to 4, then it is possible that we can convert all the number to that number 2 only. So this was my approach. If I show you the code, okay, I tried the brute one after the contest. That is the approach. So let me show you the optimized one. Yeah. So as I told, I take a map for each element. We are starting with operation 0 and counting how many operations are taking. Like in each operation, we are incrementing it by 1. You can see here, and in each operation, we are dividing it by 2. And if our elements become zero, we are simply breaking out three. And for the first part, uh, here, like in my code, I show you like here I am in first pair I am storing frequency, but in my code, in the first part, it is storing the operation because we are adding operation here. And in the second part, like in this pair part, we are storing the frequency. That's why when we are comparing, we are taking the second part, that is this pair, and again second, that is this one. So we are comparing the frequency with the total number of elements. If it is equal, then it is the candidate of answer. That can be the answer. So this is the optimized approach. Have you any doubt in this question?
No, yeah.
Okay, I hope this is clear. So next question will be discussed by Subhajit. So thank you.
Hello, am I audible and the screen is visible? Okay, so Arnav, I guess only Arnav is here. Have you read the questions after this, the and or conversion question?
Yes, we have, but
Any
wasn't.
approaches, any approach, any idea? How would you go for it? Anything?
Mm, I can't think of anything. I mean, I am not much able to recognize the bit conversions. Sorry.
Okay, okay, not an issue, not an issue. We will discuss about it. So let me just give a summary of the question that we are given two strings, right? We are given a string A and a string B. Both are binary strings. Now, what we need to do that we can do two types of operations. That is, we can take two adjacent elements, A of I plus 1, and replace both of them with either A of I or A of I plus 1, or else A of I and A of I plus 1. And we need to tell that by doing these operations as many times as possible, can we convert this A to B? Am I right? Was this the question, Arnav? I mean, are you clear with the question?
Yes, we are.
Okay. Now, whenever you see any bit question or you see something that we can do like this, means any type of bit manipulation in the binary string, always think what physically does it represent. Let me show you one thing. Suppose the two adjacent elements are 0 and 1 or 1 and 0, whatever. So if I do a OR operation, then I'll get 1. That means both of this become 1 and 1. If I do a AND operation for this, then both of this become 0 and this entire thing becomes 0 and 0. So can you just understand that in the OR case, what actually is happening is that we are stretching this one. We are stretching this one and bringing. Else, in the AND case, we are stretching the 0, removing this one and putting a 0. Is this visualization clear?
Yes, we are.
That means, think about one thing, that suppose I have a binary string, a alternating binary string like this, 0 1 0. Now, what I can do is I can either stretch this 0 this side and make everything 0 0 0. I can stretch this 1 on left or right, whatever possible, and I can make the entire thing 1 1 1. I can make this 0, 1, 1. Because whenever I have something, for 1, I have the option of OR, and I can stretch it on both the sides. And if I want to make 0, then I have the option of and stretch it on both the sides. That means without seeing the entire form of A or B, I will see the compressed form of A and B. Okay. Now, what do I mean by compressed form? Let me give you an example. Okay. Suppose A is 10010, and B, let us consider it's 11000. So if I compress this A, then what I can tell that it is 1010, because I can assume that somehow I have applied these operations and stretched this 0 on the left side and made this. Also, this one I can compress into 1 and 0. What I can think is, by applying some operations, I have stretched this 0 on this side and this 1 on this side and got up to here. So all I need to check in this question is the compressed form of B a subsequence of the compressed form of A? Because you see, whatever the structure of A is, we cannot change the structure. See here also, we are stretching a 1, but we cannot bring up a new 1 and put it in some position. Okay, like if my what is that? B has 1 in the starting and A has just 0 in the starting, then we can never bring a 1 here. No way it is possible. If we have some 1, then we can stretch it. And even if there are some zeros here, we can stretch this 1 and make all of this 1 to match the 1 in B. So this check that B is a subsequence of the compressed form of A. The compressed form of B is a subsequence of the compressed form of A is what we need to check. Because what it means is that the compressed form of B must be present somewhere in A, so that the way we have extended B on both the sides, that similar way I will extend this part from A from both the sides and make it into B. Can you get the idea of this? And
Yes, Bhaiya.
so, don't you think the question is nothing after this? Like even the implementation is also nothing. So, I mean, the explanation of the question is so simple once you understand this painting idea, though you will need a good combinatorics idea for the version 2 of it, which I'll explain. So, just tell me if you have any kind of doubt in this.
No, Bhaiya.
Okay, you got it. So, I'll just for once show the code. Do not focus on the code a lot because you should write the code on your own. Okay, study a bit about this. I guess I have taken the STL class. So in that, I remember I have taught about erase and unique. So you can use erase and unique to compress the strings. Okay, read about it. And once that is done, all you need to do is check that if B is a substring of A or not. Remember, both of these small concepts are very important for your implementation and knowledge. Not just for this question, finding if one string is a substring of another is very important. Learn about that. Compressing a string as fast as possible, learn about that. Your implementation skills will be improved. And other than that, the entire code of this is nothing. Okay, let us move to the next question. I mean, the next question is the version 2 of this only. What this question tells is, suppose you are given A. That means I have given you what is A. All that you need to do is tell me that how many possible B strings are there, which is a good pair with A. This count I need to give. Okay. Now we have the idea of the previous question, and now we'll tackle this question. How do we tackle this question? So first, let me think that suppose in this question also, I have compressed A and let the compressed length of A. Suppose A has become something more small after compressing, and let the length of it is K. And this is an imaginary B, imaginary B. Let me suppose, like the previous question, I have compressed this imaginary B, and this have formed a compressed binary substring, I mean a binary string of length L. Okay. So both of this is after compression. Initially, the length of both is N, all right? I need to find how many strings of length N, that is B, is possible so that it is a good pair with A. As input, I will be given only A. So after compression, let me suppose this becomes of length K and this becomes of length L. Now, let me tell you a condition and you tell me the reason. If L is greater than K, then it is impossible to find any such string B. This is never possible. From the idea of the previous question, what I've explained, that how do we check if B, A can become B? Arnav, can you tell why this condition is important? And from this condition, we can tell that it is impossible.
Because B, the compressed form of B should be a subset of compressed form of A.
Perfect. Absolutely correct. Thing that B should be a subsequence substring of A. So B's length can never be bigger, means the compressed form can never be bigger than the compressed form of A. Absolutely correct. Now, if L is equals to K, then Arnav, can you tell how many such strings will be possible? Means how many possible B will be there if L is equals to K?
Only one.
Absolutely correct. Only one is possible, and that is the exact match. Right? Both should be exactly equal, the compressed one.
Yes, we.
Perfect. Now, our final and most important case where we actually need to use the combinatorics. That is, if L is less than K. Okay. Now, if L is less than K. Now, let us see what possible B can be there. This is very important thing, like do you understand one thing, that these compressed ones will always be alternating substrings? I mean, they will either be like this or either be like this.
Yes, we.
Okay, so now you tell me that, let us see this as a story. Okay, suppose there are n, as we know that the size of B is n. So let me draw something like this. Think of it like a wall. Okay, it is an wall, and you need to paint this wall. Now, if this wall has, these are blocks in the wall. If there are n blocks, then there are n minus 1 gaps between those blocks. If there are n minus 1 gaps, then see one thing. What I can do is, if I select L minus 1 gaps between these N minus 1 gaps, and only and put a fence on those. Suppose I put a fence like this, and I give you a constraint that you can change colors only after you cross a fence. That is, initially, if there is no fence, then you have only one choice, that is to color every, not, let us not consider color. Either you can put 0 on all the places, or you can put 1 on all the places. So both of this will compress to something of length 1, either 0 or 1. Okay. When we are choosing 0 out of all the places to put a fence. Now, what if I put only one fence? I can put it here, then I can make it this. I can put the fence here and I can make it something like this. Or else I can put the fence here and make it something like this. In all of these cases, this will be compressed to some string of length 2 always, which is either 1 0 or 0 1. Similarly, if I put uh, here, if I put 3 fence rather than 1 fence, then you see what happens. That is, any 3 fences, I can give this, this, and this. Then I can make it 0 0 1 0 1. That means whenever I get a fence, I alternate the thing. So, what did we see? That out of n minus 1 gaps, if I choose L minus 1 gaps, then I can be sure that the compressed string that will be formed from this string will be of length L. Is it clear enough, this example?
Yes, Bhaiya.
That means in how many ways can I do this? It is n minus 1 CL minus 1, correct?
Yes, Bhaiya.
That's it. The question is solved. Whenever you have L is less than K, all you need to do is that for all possible L that is less than K, you need to find N minus 1, CL minus 1 and add them. For L equals to K, for that one case, you'll have a 1. Also, did we miss anything in this or not? Also, tell me, did we miss anything in this formula?
Uh, I guess there are two ways to do it.
Yes, absolutely. Absolutely correct. You saw this and you remembered, right? That it can either start with 0 or it can start with 1.
Yes, yes, Bhaiya.
Yeah, in this case also it can be either all 0 or it can be all 1. So all we need to do is multiply this entire thing by 2. That's it. This was the question. Once you understand that substring thing, it's all about maths and combinatorics and nothing else. You see the question? I found what is the compressed string. I found the length of it. Then for all length from 1 to k, I do NCR of n minus 1, L minus 1, and the mod that they have told. And I continue to add that. Remember, again, one more thing. In your template, I had it in my template, that is NCR and NPR implemented and pre-computed form of that. But whenever first time you are putting it into your template, implement it on your own ones. This will improve your implementation skills. NCR and NPR, implement it on your own, see it in some materials. I'll do one thing while sharing the material of this one, I mean the YouTube video link. I'll give a material from where you can see this, okay, the NCR and NPR implementation, and then the question is nothing. So are both the questions clear?
Yes, Bhaiya.
Okay, so let us end the meet here. The PCD is over for today. If you have any doubts, you can ask, or else you can leave the meet.
Thank you, Bhaiya.